I'm the .NET guy, so maybe I'll come over here with my people.
Yeah, I started, my development world was in Java, initially doing C, whatnot. But real quick about me, I'm going to try to keep this really quick. We have a lot of material we want to talk about today, and doing some hands-on demos. But really quickly, a SANS instructor, so I teach the secure Java development class for SANS. OWASP, who's familiar with OWASP? There we go. I want to see more hands than that. Come on, people.
Come on, it's free.
All right. Yeah. So I had the Denver chapter, and then we just got a bunch of letters.
So I'm Aaron Cure. I do the same thing as Steve, only I teach the .NET class for SANS. Also, any Node developers in the house? All right, perfect. So I do a lot of the scripting language kind of stuff, and so that's kind of a lot of our stuff. So just the old disclaimer, right? Everything we're going to do is live hacking using real tools, so don't do this without consent. And remember, you always want to get written consent because people tend to forget when they get hacked, right? So, all right. So we're going to talk about 5 different vulnerabilities, if I can count 1, 2, 3, 4, 5. Yeah, perfect. So we're going to start off talking a little bit about Sdlc. Everybody here following Sdlc? Right? Cowboy style? That's an Sdlc, right? It's just a whole different style. So, go ahead, Steve. You look like you want to say something.
Yeah, so really quickly, the basic life cycle we always have. We have the requirements, we have planning and design, we have the development taking place. We do a lot of penetration testing, application penetration testing, and we always find lots of issues. And we're really trying to get security in here. So next slide.
So our goal is to put security into every single step of the Sdlc, right? We want everybody to be thinking it, whether it's QA, developers, anybody, right? We should all be thinking security.
So over here, one of the fundamental aspects when we're talking about security, we need that training. I can't tell you the number of times we go to developers and, they're familiar with things like cross-site scripting, they're familiar with things like SQL injection, but they don't know how to fix it. They don't know how to avoid it. And that's the whole reason we want people to know about these issues is so they don't code it up. So we really want good training. In the requirements, we're not going to get the security stories. Too often, we're just doing functionality with no security stories.
When you write unit tests, do you write happy path unit tests? Right? That accomplishes the requirements, and we're good. Does anybody write evil user stories? Right? So, as a user, I should be able to do this. And as an attacker, I want to be able to do SQL injection attacks, right? So we should have both sides of that covered with our user stories, with our use cases.
Yeah, for example, security stories. As an attacker, I should not be able to access another user's data. Very simple. But I tell you, I was on a review a month ago, and I was able to access every single user's data. It was trivial. And that user story clearly was not there.
Threat modeling, everybody update their threat model with every sprint? Yeah. Anybody here actually have a threat model? Yeah. So we want to do threat modeling. Why? We want to know what our attack surface is. What are we actually trying to hit? Who's coming after us? What are we trying to protect?
And then one of the things we really want to do, we want to get static analysis in place. As we're developing code, as we're writing code, we want to have tools help us find the security vulnerabilities as we're identifying them. And we're going to be doing a talk about this later on in the afternoon.
Yeah, if you want to come check out the Puma talk this afternoon, we're going to do some secure DevOps with some static analysis built right into Visual Studio. So it's kind of sexy. So basically the idea is that we want to always be thinking security, whether it's from the development side, from the business side, wherever. So we're going to talk about our buddy George.
So George, he works for a large web and oil gas company, and he got a little upset with Firefox.
They're so rude. They keep putting that his login is insecure, right? They just threw that up in front of all of his users. His site's been 15 years.
Safe, completely secure,
Completely, never been breached in more than 15 years, and their notice is causing concern to their subscribers.
So let's see what happened. What is he talking about? So we're at oilandgasinternational.com. There's no HTTPS.
It's not secure because it's not secure.
These people are logging in over straight HTTP.
But login is not secure. Well, yeah, because what can I do if we don't have an HTTPS tunnel? Come on, don't be afraid. Shout it out. I do man-in-the-middle attacks, right? That stuff is transferred in the clear. How many servers does it go through on the internet between my browser and your web server? 1 or 2? 11, a million, right? We don't know. It can go anywhere along that TCP path.
So those emails and passwords are completely compromised, both for individuals, but what's nice, this oil and gas company had corporate logins. They had corporate logins, which we like to see.
Yeah, that's always fun, because if I can get a single user account, that's fun, but if I can get a corporate account, I get lots of users.
So George actually submitted this to Firefox, and it goes onto the site, and everybody's reading this. Of course, there's security people reading this, and they quickly realize that George, who thinks he's never been hacked in 15 years, oh, he has.
So,
and if he hasn't, he sure will be really soon.
So the first and most obvious issue, right, is A6, right? The OWASP top 10 are listed A1 to A10. A6 happens pretty often. It's called sensitive data exposure. And it's basically when any of your data leaves your site in any way that you don't expect it to, right? If we're displaying social security numbers, if we're throwing any other kind of information, there's a potential issue for that display. So how do we fix that?
Well, one of the things we do, one, clearly we want to be using HTTPS. So get your TLS set up, run TLS. We want to see versions 1.1 or 1.2 right now in TLS. But there's some other things you can really do. We want to emphasize security headers. Those are the things you're putting in the headers of your responses. The browsers that we have can do a lot of things for us to help us from a security standpoint. One of the things we do want to do is set the HTTP strict transport security header. All that does is it tells the browser, whenever they come to access your site, make sure you only request it over HTTPS. There's a lot of tools and attack tools that can be used to strip SSL out and try to force people to come over straight HTTP, and then we're listening for that traffic.
And there's projects that'll do these for you. So in .NET, the shim project will actually throw those headers in the top. In Java, there's the Java Secure Headers project, and all these are out on the OWASP website. They're free. And the headers are so simple to inject. They're literally just a header that says don't allow non-secure connections, don't allow cross-site scripting, some things like that that will make our site a lot more secure. All right, so the next thing we found on George's site was a stat trace. Anybody ever thrown one of those on your site? Ever seen one of these? These are my favorite as an attacker. I love it when you throw me one of these because it tells me so much fun stuff. I mean, I even get to see your code. That's friendly. I can make some judgments about you as a person, right, based on what code I see. So this is kind of an issue, right? This is a security misconfiguration, A5. So anytime that we're throwing information out that we shouldn't, we're going to kind of cite this, call it out.
And the big thing with this, a lot of times people think it's just ugly to show those error codes, those error responses. As an attacker, what we do is you can basically fingerprint the backend server based upon the messages they have. And then we will fingerprint the backend server and then identify what vulnerabilities are associated with that server.
What server is this running? Anybody? IIS, right? What version of .NET are we using?
Right there, thank you. Okay, what can I go against .NET version 2.0?
Anybody know any vulnerabilities that were in .NET Framework 2.0 but maybe were fixed in 3 or 4 or 4.5 or 4.6, right? So as an attacker, I have lots of fun stuff to say. Oh, in 50727, there's actually a remote code execution vulnerability. Thanks, that's friendly. So how do we handle these? Well, the one thing we want to make sure we're doing is doing a custom error handler, right? So we want to make sure the debug is turned off in the .NET project, or in a Java project, we want to make sure that in the
web.config.
The web.config is .NET.
Web.xml.
There we go. So I told you I'm not a Java guy. We want to make sure the debug's turned off, and then we're only returning a single error page, right? So if they hit a 404, what error code do we want to return? Nope. It was a good guess. We want to return a 200, right? We want to return the error.html page that said an error occurred and our people are looking into it with a 200 success code. Because the error code was returned correctly, right? So we want to make sure we're logging that. But what happens if they try to get to some place that they can't, right? So we want to turn back an unauthorized exception. What should we return? What's that? 200 every single time. We always want, because what can I do with those error codes? I can turn around and I can do things like a padding oracle attack. I can know what kind of errors that I can control on your site, and I can make security decisions based on that, or attack decisions based on that. So always at 200, always error.html.
Yeah, and sometimes I see people just do custom capture and custom error codes for 404. Yeah, 404 is a very common one to capture. But what's the error code for something like method not supported? Normally our methods we're sending our gets and posts, right? Well, what if I send a delete, or what if I send a made up error? That'll trigger an HTTP 503 error. And so
Yeah.
we need to be aware of that.
I'm taking this side down.
Okay.
So, in this case, an input string was not in a correct format. So what does that mean? Well, it gives me a little bit more information about what I'm looking at, right? So in this case, I'm thinking I can do more fun, right? A1, injection. Anybody like this? This is my favorite vulnerability of all time, right? Injection, it covers so many fun things. It's basically a text-based attack against a back-end parser of some sort. So what kind of back-end parsers do we have? Database, right? Database is just a text parser. What do we feed it? SQL. How about NoSQL? Is that a back-end parser? Absolutely. What do we feed it? JSON, right? Like in Mongo, we can throw in JSON. What about command prompt? Right? It's a text parser. So any of these things that I can stick data into, I can turn around and control. And that's what this is all about. So
Let's do a demo.
you want to do a demo? That'd be kind of fun. Well, so this is the most common injection, right? This is one of my favorites, because what happens when you go through a traffic camera and they shoot your picture and then they OCR it and say select star from table license plate where license plate equals tick or 1 equals 1. Right? I'm winning. I haven't got a ticket in years. But, you know, you'd be in good company if you were hacked by these things. So Target got hacked. Right? Everybody heard about Target's big POS hack 3 or 4 years ago at Christmas?
Yeah.
Well, this isn't that one. This is the one that happened a year later, where they hit their online shopping site and got all kinds of fun information.
Yeah.
Or Living Social, who lost 50 million records.
Yeah, Equifax, we lost 453 million. So, again, what we're doing in SQL injection, command injection here, we're just taking untrusted data coming straight from request.getParameter, employee ID, coming straight from the request, it's untrusted, and we're putting it live, concatenated into a SQL query.
Yeah, so right here, just concatenated SQL, right? Or right there, we're actually just taking an exec statement and throwing untrusted user input right to it. So what's it look like in the real world?
So we're going to be making use and demonstrating a little tool called SQL Map. It's a nice little attacker tool. And what's the cost, Aaron? How much did we pay for this last time?
It's pretty expensive. I think it's, it's free.
Yeah, free. We're going to use this and explore it. It's written in Python, but it's a really good tool. We use it all the time when we're doing penetration tests. It's just nice to automate some of the attacks that are out there. So setting this up, we're going to get a virtual machine going here.
Keep talking, Steve, do a little dance.
Yeah, and one of the things when they're talking to some developers, they're kind of curious how we're getting data out. For example, in the demonstration we're going to be querying for a case number, and it's returning one record. So if I'm only returning one record, are they going one at a time trying to get these things out. It's not the case. So let's real quickly do a search for 42.
Okay, so case number 42, search. And there's case
Yeah,
42.
it's a little slow. All right, so we got 42. Okay, let's just do the search for 42 or 1 equals 1. What case number do we get back? We got case number 2, so it's picked up the first record that came back. 42 or 1 equals 1 is returning a whole result set because 1 equals 1 equals is true. Okay. So, how do we exploit this? What are we going to want to do?
So when we do this, we can tell that we're obviously playing with a SQL in the back end, right? Because when we say 42 or 1 equals 1, now it's actually letting me play with that SQL that lives in it. So let's go mess with it some more.
So we're going to be firing up a tool. It's called Burp. Are you guys familiar with Burp as an interception proxy?
Everybody use Burp as a tester?
Yeah, please
use
do.
Burp as a developer?
Yeah.
The only problem with Burp is that it's expensive too.
Oh yeah, yeah.
Oh
yeah.
wait, it's free.
Yeah, you got a free version out there. There's a professional version which is like $300 US, but we're using the free version and it's good enough for what we want to do now. So what we're doing is we're intercepting the traffic through Burp, and you can see this case. We did the search for case number 42. This is the request as it was sent to the server. And we're going to save this item off, and we're going to send it into SQL map. Because the guy who wrote SQL map knows a lot of attackers use Burp, and it's going to be able to ingest that query and run some tests against it. So we save that request off, and this is, we have started SQL map right here. Okay, let's first look into what is in that file. And basically it's an XML representation of the request. It's going to have the session cookie that was created, and it's going to send that along for us. So Aaron, why don't you run SQL map and pass in that request, which is -r, sending that request, and let's let it go. So SQL map is running. It has this nice feature that's looking to see if there's CSRF tokens in there, and we're going to let it just handle the CSRF tokens.
One of the nice things, you can see that the default here is no. There are some really sane defaults in this, so if you don't really have a particular opinion about it, you just say, okay, he does a really good job. So the backend database is MySQL.
Yeah, it's already gone in and identified the backend database.
Well, that's pretty easy.
That wasn't too hard. Okay, so let's focus the attack on MySQL now.
Oh,
so
look
look,
at that, Steve.
Can you point out that one? I can't reach it.
Sure.
So it's already gone through and said the parameter case number is injectable. It's identified it as injectable. Now that we know it's injectable, do we care? We don't need anything else. Once we have one injectable point, that's all we need. Now we can go and exploit this.
How many passwords do I need to get into your system? Just one. And how many injectable SQL injection points do I need? Just one.
So let's go exploit this. So in order to exploit this, we're going to say, okay, we're still going to use that 42 request. We're going to specify the database that is the backend system. So he's going to specify that it's MySQL.
So actually I'm going to say --DBS, and that lists all of the databases that are on the server.
So up there, as you can see, it's already gone through and identified, hey, there's a customer service database, there's an e-commerce database. What's really good is this sys database. Now I know that this database is running as a privileged user.
The fact that I can see all those databases is probably an issue too. So what should we go after? Which one looks the most interesting? Come on, shout it out.
I like human resources.
HR, right? We're all a bunch of nosy people. We want to know all the stuff about all the people.
I want to see who's being paid. Okay, so we're going to be using our SQL map tool, specifying the same request. We're going to go look into the human resource table, and let's get a listing of the tables.
That's
Okay.
great.
So it's already gone through and identified. We have an employee table, minimum employee role, and then the roles. Let's find out what's an employee. What do you think that dash dump does? Let me tell you, I was doing a review of a healthcare application, and they had a SQL injection vulnerability on their login page. So I was about 5 minutes into the review, and I called our client up and just said, hey, I'm dumping your entire database right now. And it was beautiful. And let's look at all that stuff flying by.
So you can probably catch a little bit about here, but there's social security numbers, bank account numbers, name, all kind of email address, all kind of PII, right? It's just fun. And it'll just continue to dump thousands of these out. So it's going to stick it all into a CSV file, which is nice for me because then I can just go back and look at those records later. But yeah, you can see all these fun employees, right? Kind of a scary tool, just a little bit.
But I mean, this tool is widely used. Attackers are using doing drive-by SQL injection attacks. So anytime someone's writing their code and they're doing that dynamic concatenation of their code, putting untrusted data directly into a SQL request, you're doing that. You potentially can have your database dropped.
So how do we fix it, right? How do we make SQL injection go away? Well, two simple ways. Parameterized queries, right? Every single database access layer out there has a parameterized query, right? There's an easy way to do it. Or even easier, you can use an ORM. Anybody here using ORMs? Right? Hibernate and Hibernate, EF, those kinds of things, right? Those kinds of things automatically parameterize. So there's no more building SQL. You just let the tool do it and they parameterize all the stuff.
And the one thing I do want to mention is parameterized queries. A lot of times, especially in the Java world, we just say, hey, just use prepared statements, right? Yeah, you can use prepared statements if you want to parameterize your queries, but I've seen people do that wrong, where they actually concatenate into part of the prepared statement. You actually have to parameterize every untrusted input.
What about stored procs? Stored procs are safe, right? Anybody using stored procs because they're safe? Can you do SQL injection in a stored proc? Absolutely, all day long, right? If you're building concatenated SQL in your stored proc and executing it, executing it inside there, you've still got the same problem. We can still do SQL injection. So don't think just because you're using stored procs, you're safe. All right, so remember our friend George and his single error page? We've got a lot of information off this so far, right? We already know that we've got a SQL issue. We already know that we've got a data exposure, and we've also got some information down here, right? Tells us about the .NET framework, what version is being used, that kind of stuff. So let's talk about cross-site scripting. Anybody ever heard of XSS? A couple people? All right, so what is it? XSS is when I can run my own scripts, JavaScript and that kind of stuff, in your website. Right? So I can tell your users that, hey, you need to click here, or I can redirect them to another page, or I can throw up the alert box of death. Right? So this is the alert box of death. Anybody ever seen XSS demonstrated this way? Right? Oh, look, there's an alert box. Right? It's pretty scary. So whenever you see the alert box of death, I want everybody to go, right? Because it's scary. What you can do is just beef. Oh, I can do it over there. So this is one of my favorites, right? Sears had an XSS vulnerability where they were building their breadcrumbs off of what came inside the URL parameters. So they kind of made it a little more interesting. Or the EF Foundation, the epilepsy was actually hacked, and this one sent people to the hospital. So it's the only web attack I know of that actually caused physical damage to people. So that one's not cool. But basically the idea is we're running unencoded data straight into the page. Untrusted data written directly into the page. So when we talk about untrusted user input, what are we talking about? Where's it come from?
You get it coming from the users.
Right? Text boxes, URL parameters. What about headers? Headers are safe, right? Because the browser manipulates those. Can we trust headers? No, why not? Because I can use things like burp and do a man-in-the-middle attack, right? Simple. I can put anything I want in the header. So we trust anything coming from the user? Come on, do we trust anything coming from the user? No, absolutely not. What about the database, though? We own the database. So we can trust the data that's in the database, right?
But where does that data come from? It comes from the user. It comes from untrusted third parties.
It comes from the HR department who decides that they want to take and tie their Excel spreadsheet directly into the database so they can update people's records and they put whatever the heck they want in there, right? Do we trust the database? No. In fact, do we trust anything? That's right. Trust no one. Now, if you take one thing away today, it's trust no one. So let's talk a little bit about what XSS looks like. So, I'm going to get back over there.
So we're going to be running a tool. It's called DEV. It's the Browser Exploitation Framework. And the reason we run this tool, XSS is what we call a gateway vulnerability. One, it's almost everywhere. It's pretty rare for us to review an application and not find cross-site scripting vulnerabilities. And when I go up to a management, CEO, CTO, and show them this alert box of death, it does not make money flow. They say, oh, someone can do a pop-up on my screen. I don't really care about pop-ups. So we like to have this tool to show that a little bit more about what you can do with XSS.
So in this case, I'm just going to take a standard website that has a SQL injection a cross-site scripting vulnerability. And you can't really see it, but right here, I've just got a script, alert, XSS, and close the script. And if I run this as part of my search, it should pop up. Let's try it in another box.
Submitted.
Weird. Very strange. So, theoretically, it pops up, and you're going to see the alert box. But we're going to play with a better tool anyway.
Yeah.
So this tool is actually called BEEF, and it's the Browser Exploitation Framework. So if anybody wants to play along and play the home game.
Get you in first. Let's get you in first. So there's a site we have out there. It's on AWS. It's b33f.me. You are hitting a site that's going to inject you.
So if you hit this site right here, right, we have a standard 404 request, right? 404 return says that IIS can't fulfill your request because that doesn't exist. Right? Except this is running on Apache, on an AWS server. And this is just a page that it serves up that has a beef hook in it. So there's just a little bit of JavaScript. So if you go to b33f.me, you should show up here in this nice little list. In fact, you can see that I already hooked myself.
Yeah, so he's hooked himself right now.
But feel free to join in. We won't do anything malicious. You can trust us. We're security guys. I'm not feeling the love, Steve.
I'm not.
Wow.
Well, let's see what it can do.
So, social engineering is one of my favorite spots to live. So, let's start off with this one right here. And this is just called the fake flash update. So I can put in whatever download I want right here, right? And I hit execute. And what happens over here on our site?
Anybody ever see this? But fortunately we know that when this pops up, if you don't want to install it, you can just, hey, remind me later.
Well, the other thing is we have not trained our users to click on this, right? Nobody at work would click on this.
Because you never see it, right?
It never pops up, right? We never get an Adobe Flash update. Oh wait, we always get an Adobe Flash update. So what do our users do? They hit install, right?
But we don't want to do it now.
We can say remind me later. It doesn't matter. It's still going to download it. And what are they going to do? They just told it to install Flash, now it downloaded a file. What are they going to do with that file?
Save it.
Run it, right? Absolutely they're going to run it, because that's what we've trained them to do. So, that's kind of an issue.
What about if I'm logged in, if I want to check it out on Facebook or something like that?
Oh, well, so, you know, there's some neat little things like here, like Pretty Theft is one of my favorites. So, we can pop this, and boom. Anybody have that friend at work that can't get through the day without their Facebook, right?
Yeah. Well, you better log in. You don't want to not be on Facebook.
If I don't get on my Facebook, I'm not going to be able to see anything. So, my email is hackme@please.com, my password. And I'm going to log in.
Well,
whoo!
You're still on Facebook.
That was safe.
Still on
I thought for sure I was going to get logged out of Facebook, and then how am I going to go see those kitty pictures? Right?
On the attacker side, this is what we're seeing.
That's killing me.
Isn't that nice to share your password? But is that just the only one you can do? Just get Facebook?
Well, yeah, so we have a policy at work that says you can't use your Facebook account. So we're safe.
Let's do another one.
Okay? So you can see right here that I got your login and password for your Facebook account. Right? Because that's a friendly thing to do. But okay, so you're telling me that you have a password, a policy at work that you can't hit Facebook, and we block it through the proxy. No problem. You guys use this at work?
Is that one potentially a little bit more useful?
So I did a phishing attack last month against a large municipality's police department, 2,600 police officers, and I got 26% of them to give me their corporate login and password. 26%. Another 14% clicked on the link and went to my website. If I had a drive-by download, they obviously would have gotten hacked. Done deal. I mean, we're talking simple things here that people are going to fall for. Right? So I can go ahead and put in my corporate username and password. Save that. And now, you can see right here that
Zoom in on that one.
there's my username and password. Right? Same thing, easy. So there's also some fun ones in here. This guy's one of my favorites, right? Remember this guy?
That's cool.
Haven't seen Clippy in a while, right? Hey buddy, where you been? Your browser appears out of date. Would you like to upgrade it? Why, yes, I would. Wait a minute. I'm in Firefox. There's no Clippy in Firefox, and he's pretty much impossible to get rid of. Kind of like the real Clippy, so it's actually a pretty good implementation. But my actual favorite lives right here. And I can just redirect your browser anywhere I want. So I'm just going to say go. Right? I mean, that's just quality right there.
Oh yes.
There you go.
Now we're good.
Now we're set.
So that very simple thing, that little cross-site scripting window that pops up, it doesn't scare anybody. But when people realize that I can compromise your network credentials, suddenly this becomes a little bit more of a gateway vulnerability because it gets me into your system. I can pivot and do a lot more stuff with that. And cross-site scripting is everywhere. So what do we do about it? Encoding. A lot of times we try to do just input validation. It's very difficult to do that properly and mitigate this.
So what are we talking about when we're talking about encoding? Anybody know? How do we encode? What are we encoding for? Yeah. What's that? And we're escaping special characters, right? So in HTML, what are the special characters?
Yeah, greater
Less than, greater than, right? That's the main key. If we can make those ampersand LT semicolon and ampersand GT semicolon, we've fixed 90% of the cross-site scripting. But there's libraries that automatically do that, because do people know the other 42 characters that are a problem in HTML? What about in URLs? In JavaScript? Right? So if we can turn around and encode those to make them safe characters, we can get rid of XSS. So that's what we're talking about. You know, the HTML.encode methods, the server.encode methods, the libraries that will actually do this for us.
Yeah, we usually see people understand and utilize HTML encoding, and that's fine if you're putting untrusted data in an HTML context. But if you're putting things into a URL, you have to use a different encoding method because you have different special characters that need to be encoded differently. JavaScript especially, different encoding methods. So not only do you have to encode, but you have to be aware of where the untrusted data is going and encode properly.
And you're gonna have some crossover sometimes, like HTML attributes, right? You get your main tag and then you've got an HTML attribute in there like href. Is href a JavaScript context, a URL context, or an HTML attribute context? Yes. Right? It really depends on what we're putting in there, but you can do all three. You can do an href of JavaScript colon, you can do an href of go to an actual URL, and it's an attribute, so there are particular things that will show up in there too. So basically, as long as we're encoding, life is good. So there are specific libraries for every language out there. .NET has a lot of them encoded. You also are included, so that you can also add some more. Spring Boot's got default encoders built in, and most of the libraries like Timeleaf that do the rendering will actually encode by default into HTML context.
And in the Java world, yeah, you know, if you're using Spring Leaf, things like that, Spring. But if you don't have an encoding library offhand, the OWASP project, there's an OWASP project, the Java Encoder project. It's written by Jeremy Long. Really good project, and has all of these encoding methods in there.
So the other two things we want to talk about, we talked about security headers earlier. There's two here, XSS protection, or X-XSS protection. This one stops it from running inline SQL, so it stops you, or inline JavaScript, so it keeps you from reflected XSS attacks. And then a content security policy. You can say, only load JavaScript from these sources. Only allow images from these sources.
This is a very powerful one. But a lot of legacy applications where you're doing inline SQL, the CSP does not want to see any inline JavaScript.
So if you're using ASP.NET or any of the other embedded that uses JavaScripts to perform the callbacks and that kind of stuff, you have to pull all that inline JavaScript out and put it into externalized JavaScript files.
But it's a very powerful thing. Now we're going to do one final thing. How many people are familiar with cross-site request forgeries?
CSRF, right?
CSRF. Yeah, I'm glad to see a few more hands showing up. It used to be that there would be nobody raising their hands. And
this vulnerability really bothers me, by the way, because cross-site scripting is XSS, but cross-site request forgery is CSRF.
But it sounds better, CSRF.
Oh yeah, XSRF is kind of weird.
But what is this? Let's talk about, let's skip the slide here. Let's go into here. Who here ever does this, opens multiple tabs? Anybody? 2 tabs
in the same time? I mean, we don't do that, right?
Everybody does. I mean, there's 30 or 40 of these things popped up. What does your browser do when you, in this session, if I go to my banking website? So say I go to mybank.com. I log into mybank.com. And it's tracking my session. How is it tracking my session?
Cookies.
Cookies, right? So anytime the browser, your browser makes a request to mybank.com, it goes in and says, oh, Steve is making a request to mybank.com. Let's dig into my pocket of cookies and see if there's one from mybank.com. Oh, there it is. So I'm going to send my session cookie out. But what happens if I'm logged into the Bank of America and in one of my other tabs, say this one, they make a request to Bank of America? if the request originates from a separate attack site, will your browser still put in the session cookie?
What does it use to distinguish which of those cookies get sent? Target name, port, and protocol. So HTTPS mybank.com port 443. So if this site has a JavaScript in it that says does a post to my bank and it matches those 3 criteria, does that cookie ride right along? You bet. Who made that request? You did. Came from your browser, which you were logged in from your IP.
You did that. You made that request. You may not know you made that request, but you made that request. So what can we do with this?
So what does this look like? If we're talking about in code, right? This is just a simple form that does a post out to the same protocol, site, and port, right? Same URL, protocol, port, goes out, does a change password request in this case, and has our 2 fields.
Yeah, you do have to know what a request looks like. But I have an account with my bank. I can use Burp on my bank and identify what every single request looks like. I can find out what it looks like to transfer money. Once I do that, I can embed this request onto any page I control. So I could put it on myattacker.com site. Yeah, if you hit my site, I'll put this on there, and I'm going to send that post for you.
In fact, didn't somebody do this with some routers recently, Steve?
Yeah, there was one, and it was
TP-Link in Brazil, right?
yeah, it was actually on the default admin page for the router because nobody changes their password, and yeah, they had a CSRF vulnerability on there, and they basically took over admin of the router, all these home routers. Which, what do you do with admin as a router? You know?
You can't do anything, right? You can't override the DNS and send all requests to the top 5 banks in Brazil to an attacker-controlled website instead of the actual bank site. That's not a problem.
Well, not much. I'm sure they didn't mean to do any harm.
It was an accident. I mean, they were just proving proof of concept, right?
All right. So
then when that request gets triggered, it's going to hit that site, and what does the browser do with the cookies? Stuffs them right in there, right? Hey, let me be helpful. And then now it's going to send that data that we had and get a 200 response from the website.
Let's see this real quickly.
So
We're going to go to our site. This site we built here, we saw some references to this. Who's watched the movie Office Space? Great film, right? We have our friend Milton. He was always looking for something.
What was Milton always upset about?
The stapler.
The stapler. What was Milton's last name? Wadums, that's right. So we're going to log in here with M. Wadums.
So it was a stapler.
Capital STAPLER. Sign in. And now I'm signed in as Milton. Right? Piece of cake.
I can see that.
So now Milton decides that he's going to go visit another site, right? He's going to go over to this neat little purple site. Now, how did Milton get to this site, right? Well, so I hit you with a phishing link. Said, hey, it looks like your bank took $20 out of your account. Look here. Or, hey, look at this new great thing that you need to get, right? We get spam emails all the time. So I can pretty much easily put together a phishing link that can get you to this site. Now, the thing you're going to see in this site that you probably didn't see was the fact that it already happened. So if I come down here and I actually look at the code for the CSRF page.
Now we're making it easy for a demonstration. We're actually clicking on the links. Normally, if we were going to be executing this payload, we would just JavaScript autoload. You would just visit the site and we would see this. So if you blow this up here, you can see we've embedded a little form in here that, wow, this is hard to read now.
You're too close, Steve.
Yeah. But there's something about a new password and a confirmed password. I don't know what's going on here, but
if I come back over here to the real site and I come over to change password and I inspect that site, you're going to see that there's a form which posts to the change password page just like we're doing. And inside there, you'll see that there's a new password field and a change password field.
I don't think anything happened though. Just log out and let's see what it does.
All right, so you don't think it worked. That's fair. Let me log in. M-Wadams.
And then stable.
And capital S-T-A-P-L-E-R. Sign in. Oh, I must have fat fingered it. M-Wadams, capital S-T-A-P-L-E-R. Sign in. Oh.
Did you see Milton change his password? Milton did change his password, that's for sure.
It came from Milton's computer where Milton was logged in. So where did he actually change? Where did Milton get moved after they moved him downstairs? Storage room B, capital S-T-O-R-A-G-E, room B. Sign in, bada bing, bada boom.
That's CSRF.
CSRF's friendly, right? CSRF is your friend.
And I have to say, I would say over 90% of the applications we review are vulnerable to CSRF if there's not something in the framework that stops it. If you're using Springline security, by default it helps protect against CSRF.
If you're using .NET MVC, it has CSRF tokens built in by default. You just have to tell it to use it. Hey, validate the CSRF token. Node has CSRF. You can build it into Express framework. There's 2 or 3 different packages you can do it. So make sure you're using CSRF tokens. Well, what are CSRF tokens? They're random nonces. What's a nonce? It's a number used once. Right? It's just this random code, call it a GUID, call it whatever you want to call it, something random that you're going to stick into every page. And it's going to get submitted back with the page, and we're going to validate that the one that you sent back is the one that the server sent. Right? So we should just stick that in a cookie, right? And then it'll get automatically sent.
In the cookie? Nah.
Well, that's the problem we're trying to get around, right? So where do we put it? We can put it in the header? Absolutely, that's easy. That's the easiest way to do it with like, when you're posting back to APIs and stuff. Where else can we put it? A hidden field?
Exactly.
Right? It doesn't matter. As long as it writes back with the form, it's fine. So hidden fields actually in this case are okay. Because as long as that data comes back with the request, we can validate it.
A lot of times, if you go to the next slide, we'll show what one of those tokens looks like. Okay, next slide.
Oops, sorry, I went the wrong direction.
So here you can see an example of a hidden token being inserted. You have a large random value, and this is unique on the request. As an attacker, I'm not going to know what that number, that token is ahead of time.
Underscore CSRF is actually pretty common for CSRF token name. You're going to see that in Node. You're going to see that in Java. So those are pretty easy to find. The one thing we got to make sure is that we have no XSS. That's key, right? Because what happens if we have an XSS vulnerability, right? What does cross-site scripting do again? Allows me to run code in your website. So what happens if I put a piece of code in there that grabs that hidden field and sends it back to my server? Game over, man.
Yeah,
right? Your CSRF protection doesn't do me any good.
Yeah, so in CSRF Guard, you have an option of setting a token once per session and use the same token for the whole session. The other option you have is have a unique token per form.
And I like it per request. It's easy, it comes out, and it's constantly being rotated. So if it does get compromised, it's only good for a couple minutes anyway.
Yeah, if you use it for the whole site, for the whole session, if there's XSS anywhere on your site, you've just destroyed your CSRF protection.
So, if we turn around and add security into every single one of these steps, we can eliminate 90% of these vulnerabilities, right? We're going to train developers up front, and we're going to train QAers up front to know what to look for. We're going to start looking at some of these user security stories, some abuse stories, and try to break the code before it's ever written. And then we're going to test it all the way through. We're going to do pen testing, we're going to do static analysis, and then in the release phase, we're going to be constantly looking for that kind of attack, right? So our full life cycle, right? We want to have security in every single spot. So start thinking about that. What small changes can I make to the Sdlc to make it more secure? Now, can we do all this stuff overnight? It's impossible, right? If you try to make all these changes, what's your team gonna do? They're gonna ride you out of town on a rail, right? Tar and feather, send you out, burn the building down, right? Go Milton style. So we want to do this in levels, right? And our company motto is level up. Right? The whole point is that you're not going to become that great character overnight. You're going to have to go through each of these little campaigns, get these little wins. Let's eliminate 5 cross-site scripting vulnerabilities this week. Can we do that? Absolutely. HTML encoding on 5 different places. Static analysis will tell us where they are. Go find 5, knock them out, move on.
Yeah, but continuous improvement is key.
So what can we do today, right? What can I do today to my project to make it more secure?
One thing, security headers is trivially easy. It is so easy to do. Just pop it in every response. You can do the CSP header. You can do the x-XSS header. You can do the HSTS header. Really quick and easy things to do, and it provides decent blanket coverage initially.
And if you add one of these modules in, like the shim module, the Java header module, or any of those, you stuff those into your project, it automatically adds them to all the pages. Done. That's a 2-minute fix to a ton of problems. Then we want to move in and make sure that we parameterize all our queries. And we want to make sure that we're treating untrusted data appropriately. That's a big one. That's huge, right? That's a bigger conversation than, can I throw this into my project? But we need to start asking that question on every single form that we create. Every single database call we make. Can I trust this data? And the answer is no. That's right.
And the key thing is know what data is untrusted. And I think we're out of time.
Yep. So, any questions? Catch us afterwards. We'll be more than happy to answer any questions. If we don't know the answer, we'll make it up. So, thanks for your time.